All right, new example. Use the limit definition to find these three things. So let's start right off the bat here. A, we want to find the slope of the graph of the function at the indicated point. The slope of the graph of the function at the indicated point means that we're trying to find f prime of -1. Okay, so let's plug that into the limit definition. The limit as, and we can use x here because these are x's, the limit as x approaches -1 of, on top here, is f of x minus f of -1, and we've been writing that out, but let's see if we can go ahead and, just plug that in straight away and save ourselves some writing. So f of x 2x squared minus, if I plug in a -1 here for f of -1, let's just write it out right here. That's -1 squared, so that's +1. +1 times 2 is 2. So that gives us 2 right here. Over x minus a -1. So minus a -1 should be +1. So let's see what we can do to simplify this. Up on top, it looks like I can factor. Looks like I can factor out a 2 and end up with x squared minus 1. Oh wait, x squared minus 1 can be factored. So let's factor x squared minus 1 into x plus 1, x minus 1. You can take 2 steps to do that if you want to. I mean, I just thought it might be nice if we took 1 step. So it looks to me like we can cancel out our x plus 1s. So that gives me the limit as x approaches -1 of 2 times -1 minus 1. Well, I didn't mean to put that there. I meant to have an x. 2 times x minus 1. Now we're ready to eliminate, or we're ready to evaluate the limit. So we don't need to write limit anymore. We want to say our limit equals 2 times -1 minus 1. So inside the parentheses here is a -2. 2 times -2 is -4. So that's our answer for part A, is that at -1, the slope of our graph is -4. Okay, now it wants us to find an equation of the tangent line at that point. So what does an equation of a line look like? An equation of a line looks like y equals mx plus b, where m is our slope and b is our y-intercept. Now, a common way, especially starting in pre-calc, that we like to find the equation of a line is using point-slope formula, which is this. Okay, so we know from part A that our slope is -4. So what we need to do is figure out a point that we can plug in so that we can fill in the rest of this problem. So if we look back up here, we know that we are talking about it going through x equals -1. And we actually figured out if we plug in -1 that we get 2, which means that we know a point. We know the point that it's actually going through, -1, 2. So that's what I'm going to plug in. So this is going to be y minus 2 equals -4 times x plus 1. You distribute and you also add 2 to both sides. So this gives you y equals -4x. -4 times 1 is -4 plus 2. So y equals -4x minus 2. So this is the equation of the line that is tangent to this function, to f of x equals 2x squared, at the point x equals -1. So now what they want us to do is sketch a graph of the curve near the point without using your graphing calculator. So I can see how this is going to seem kind of tricky, but I think that we can do it. So we're talking about at x equals -1. One thing that I feel like will help us is if we actually look at our graph like we're really zoomed in. Okay, so we want x to be -1. We know that it goes through 2, so I might actually make these a little smaller. Make this a little longer. Okay, so we know it goes through the point -1, 2, because when we plugged in x equals -1, we got the value 2. So we know our graph goes through this point. We know that the tangent line of this graph is going to be y equals -4x minus 2. And so basically what that means is that we know that it's a negative slope and that it goes through this point, and it's going to end up going through this point somewhere down there. So we can graph our tangent line. Well, if we wanted to graph our tangent line, it just actually wants the graph. But I mean, this basically is kind of a slope of -4. Okay, it's not super accurate, but hey, no big deal. So we want to sketch a graph of the curve near the point. Keep in mind that you know what a parabola looks like, right? And so that means that if this is the slope of our curve at this point, that basically we're saying that we're going up in this way, and then we're coming back down this way. Okay, and this would be our graph close to that point. Basically, we want to see that the tangent line is close to that graph. As we get farther from that point, you know what a parabola looks like, so we would get closer and closer to 0, 0. But at x equals -1, we have our graph that it's at about a slope of -4. Last example. So this is a different definition for our derivative, and this is actually what you're going to, when you start calculus, it's probably the one that you're going to use more often. And it's basically the same thing that we just did, but we're writing it differently. We're saying that we want to, on top of this, we want to compare f of x plus h with f of x and put it over h, and we want h to get as close to 0 as possible. And so what we're talking about here, like on a graph, is that from here to here is h, and so that means that up here on our graph we would have f of x plus h, and we would, because this is our y value at x plus h, this would be f of x. And so if this is our function, we're saying, okay, let's find this value and this value. Let's subtract them and put them over h, but let's make h as small as possible, because the closer that these 2 points get, then we eventually end up with the instantaneous rate of change, or the derivative at that point. Now, this is in general going to be easier to compute if what you want is not an actual derivative of a value. A lot of times we want just derivatives in general, where we end up with an x in our answer. So let's give this a try. We want to find the derivative of this right here, f prime of x equals the limit as h goes to 0, and it's always going to go to 0 if you're using this h definition, of f of x plus h. So that means that everywhere that x is in my function, I need to put an x plus h. So this is a little bit more complicated of one. Even if we were trying to use the other formula and find it at a point, this would end up being kind of weird. Minus our actual function f of x, so minus 3x squared plus 2x minus 1 over h. So here's the problem. If we try to evaluate this limit right now, we are plugging in a 0 where h is. The h is on top as well, but more importantly, we're plugging it in at the bottom, which means we're dividing by 0, which we can't do. So in order for us to be able to find the derivative of this function, we have to be able to simplify this top so that somehow we cancel out the h. And that's going to be basically the trick to using this limit definition of a derivative. So let's see what we can do. We want to FOIL x plus h. because it's squared. So we want to FOIL it. So x times x would give us x squared. X times h would give us xh. X times h would give us xh. And h times h would give us h squared. So let's see if we can multiply by 3 and add our like terms at the same time and write it down here. So 3 times x squared is 3x squared. Xh plus xh is 2xh. Times 3 gives us 6. And then 3 times h squared gives me 3h squared. Then I want to do this part. I want to distribute the 2 here. So this is plus 2x plus 2h minus 1. Distribute the negative. Like I said, this one's a little bit more complicated, just because there's 3 things in our function instead of just 1 term or 2 terms. All over h. Now this is where the math magic happens. Check this out. 3x squared minus 3x squared. 2x minus 2x. Negative 1 plus 1. All of that goes away so that everything we have left on top has an h in it. Look, I have 6xh plus 3h squared plus 2h. If everything has an h in it, that means that I can factor the h out and I can factor the h out and cancel. Bam, bam. Now we're ready to actually evaluate this limit. Let's do that equals the limit as h approaches 0 of 6x plus 3h plus 2. And so what happens here is that we are plugging in a 0 where h is. So I'm not plugging in a 0 for x. I'm just plugging it in where h is. So this goes away. So this equals 6x plus 2. So here's what we're saying. We're saying f prime of x equals 6x plus 2. And that means that this function will tell us the slope of this original graph wherever we want to know it. So if we want to know the slope of this function at 0, we can plug in a 0 here and find it. If we want to know at 1, if we want to know at negative 1, wherever we want to know, we just have to plug into this. This is basically the slope formula for this graph. And that's what derivatives are, is finding the slope formula for different graphs. So that's it.